closer in time.
Before getting started with today's video, we here at Closer in Time predict this video that you are now watching is destined to become the most watched video of all time. So you can step aside, baby shark dance, you rapscallions, you. Calculus! Although unlike algebra, there's little historical dispute over the discovery of modern calculus, in one of the greatest historical synchronicities, there exists a seemingly unresolvable dispute over who exactly deserves credit. History records that the development of calculus occurred simultaneously between two mathematicians whose residences were separated by only 200 or 300 miles, Isaac Newton and Gottfried Leibniz. In some sense, the mathematical art of calculus serves as a bridge between mathematics and modern technology. The key innovation is the use of limits. Calculus provides two fundamental tools: integration, which allows us to determine the area under a function, and differentiation, which allows us to determine the rate change of a function. The cornerstone of calculus is the so-called fundamental theorem of calculus. This theorem provides the result that differentiating the integral of a function produces the original function. While nowadays this theorem is widely understood and roundly demonstrable, its profound elegance and beauty is hard to overstate. Algebra. Unlike calculus, the mathematical discipline of algebra has ancient origins, having a centuries-long evolution alongside geometry. Determining a seminal milestone for the emergence of modern algebra depends not only on how we define it, but also the sometimes non-trivial task of subjectively assessing how closely one early development actually matches our definition over another. Having said that, most historians agree that modern scholarly algebra first took shape with either of two historic precedents. The most recent is the publication of Algebra wa al-Muqabala, the science of restoring and balancing, by the Persian astronomer and mathematician Al-Khwarizmi. The modern word algebra descends from the term algebra in the book's title, meaning to balance or restore. While the notation used by Al-Khwarizmi was rhetorical, meaning his equations are expressed in words rather than the nowadays familiar symbolic operations and variable placeholders, Al-Khwarizmi's work was unique from his predecessors on two key points. Rather than focus on specific problems known in particular settings, he framed mathematical relationships in a practical, though general setting. More importantly, Al-Khwarizmi detailed the process of systematically rearranging and simplifying equations to more easily isolate an unknown quantity of interest. This featured ritual of modern algebra will be spectacularly familiar to many students. Some historians bestow the title Father of Algebra to Greek mathematician Diophantus, who about 6 centuries prior to Al-Khwarizmi wrote a collection of books titled Arithmetica. Indeed, Diophantus used more symbolic notation than Al-Khwarizmi, and he detailed some rather complex problems, though his approach was not particularly systematic and his results not immediately practical for the most part. Right now, today. We are closer in time to the development of calculus than calculus was to Al-Khwarizmi's algebra by about 470 years, and closer than calculus was to Diophantus's algebra by roughly 1,000 years. Geometry. Including the mathematical study of shapes, geometry is ancient. It is essential in most every human affair, including calculating volumes and measures in commerce, astronomy for determining time and location, both essential to navigation, the surveying of land, cartography, and architecture. Numerous extant documents from the Middle East and Africa detail many applications of geometry dating from the Egyptian and Babylonian empires. Some notable examples include the affectionately named SI.427, a clay tablet from the Old Babylonian period, whose shapes and cuneiform detail methods for assessing land boundaries. Another tablet, IM67118, from the same period and region, illustrates the relation relationship between the length of the sides of a rectangle with the length of its diagonal. The Moscow mathematical papyrus from the 13th dynasty of ancient Egypt, about contemporaneous with the aforementioned tablets, offers a number of explorations in numbers, including the calculation of the volume of a truncated pyramid. This document references an even older document, currently lost to history, from the 12th dynasty of Egypt, perhaps about 100 years prior. We are closer in time to the development of early modern algebra than it to the early development of geometry by roughly 200 years.